This chapter is on writing and graphing inequalities. So an inequality is a mathematical sentence that compares expressions. So you're looking at the less than symbol, the greater than symbol, less than or equal to, greater than or equal to. So the solution of an inequality is any value that makes the inequality true. The set of all solutions of an inequality is called your solution set. So we can write inequalities by taking these words here and making them math. So twice a number x is more than negative 6. So twice a number x, we learned this before, is 2x. The only difference between this lesson, and the one before is that now we have is more than, not equals, negative 6. So is more than is a greater than. So twice the number x is greater than negative 6. 7 less than the number b is fewer than 18. So 7 less than the number b means you need b and then take 7 less than that, is fewer than, so it's less than 18. You can do the next couple on your own. So in number 3, you have 3 more than 5 times a number is at least, meaning it can be 28 or more. So it's at least 28, which means that you have to have the greater than or equal to, because it can be 28. 2/3 of a number, y, so 2/3 times y, is no less than 7/8. So it can be 7/8 or anything greater than that. So it's the greater than or equal to symbol. 4 times the sum of a number n and 2 is no more than negative 64. So it can be negative 64, which makes it the equal to piece, but it can't be any more than that. So it's less than or equal to. To win a showcase showdown on The Price is Right, the contestants' guess of the price of the prizes must be at most the actual price. Write an inequality to represent the prices the contestant can guess if the showcase is worth $13,920. So their guesses, which we're going to represent with X, can only be at most. So 13,920. So it can be 13,920 and anything less than that. So it's the less than or equal to symbol. To tell whether a solution is or a value is a solution, you simply plug it in and then solve. So if I'm saying, can y be negative 2? I stick negative 2 in for y. So negative 2 minus 5 greater than negative 6. And I see, is that true? So I solve it. So negative 7 greater than negative 6. No, it is not. Therefore, it is not a solution. So not a solution. If you plug in, let's just look at number 10, n divided by 2.5 is greater than or equal to negative 4. So if can n be negative 10? So negative 10 divided by 2.5 greater than or equal to negative 4. Well, negative 10 divided by 2.5 is negative 4. Greater than or equal to negative 4. And yes, this is a solution because although it's not greater than negative 4, it is negative 4. To graph, it's very important to recognize open versus closed circles. An open circle is when the number is not a solution, but it's the start of the solution. A closed circle is when the number can be a solution. And then an arrow to the left or right show that the graph of the solution continues in that direction. So an open circle will always go with less than or greater than, because that's, if you're talking about C is less than negative 6 in number 11, you're talking about, well, negative 6 is here, negative 5 is here, negative 7 is here. C is less than negative 6, so it can't be negative 6, but that's the starting point. It can be everything less than that. So J is greater than or equal to 8. This is going to be a closed circle. So a closed circle has to be less than or equal to, greater than or equal to, like these, because it can be that number. So when you graph this, you'll have 8 in the center, 9 above, 7 below. So J is greater than or equal to 8, so it can be 8 and anything greater than that. So you shade it in and you shade in your arrows indicating that it continues on. Fill in the rest of the solutions and check your answers with the ones that I put in there.